Hello everyone. So now, for this video, I'm going to teach Physics Form 4, Chapter 1 Measurement. And this is going to be a revision video, so I hope it doesn't take long. This chapter isn't really long, but it's important because without this chapter, you won't be able to calculate for all the other chapters in physics. So let's start. Okay, first of all, measurement. The definition of measurement is the method to determine physical quantities. We need to memorize this because in physics, in exams for physics, they will always ask definitions and we will never know what definitions it will come out. So definition for measurement, method to determine physical quantities. Okay, so what are physical quantities? Physical quantities are measurable quantities. Quantities that we can measure, okay? Measurable quantities. And physical quantities contains magnitude, which is the value, and units. Okay, so there are two types of units, which are metrics and imperial. In physics, we use metric, not imperial. So examples of metric units are meter, liter, kilogram, and etc. Basically, the units that we usually use. Imperial, on the other hand, is feet, inches, miles, yards, gallons, etc. We don't use these because their values aren't really the values are not really good to use for calculations. So remember, in physics, we use the metric units. So there are a few types of physical quantities, and in the term of base and derived, this is quite important. So base quantities are physical quantities that cannot be defined in terms of other physical quantities. This is the definition for base quantities, so we need to memorize this for exams. Let me repeat. Physical quantities that cannot be defined in terms of other physical quantities. This means that the physical quantity in this group, base quantity, it's like DOG. It cannot be calculated, it's there, and it cannot be defined in other terms of physical quantities because it's them only. So there are 7 base quantity, and this one also need to memorize. So the first one is length. The symbol is L. Unit is M, which stands for meter. Need to remember the units. Next, mass. The symbol is M, and the unit is kilogram, kg. Third, time. The symbol is T, but the small letter T. The unit S for seconds. Fourth, temperature. The symbol T, but big letter. The unit Kelvin, big K. Fifth, current. The symbol I. The unit ampere, A, big A. 6. Luminous intensity. The symbol LV, LV like Louis Vuitton, and the unit CD, candela. And lastly, amount of substance, or you could say number of mole, we learned in chemistry. The symbol is N, small n, and the unit is mole. The unit mole, MOL, or in terms of writing, MOLE. So in physics, we will only use these units, the meter, kg, seconds, Kelvin, ampere. We will use this for calculations. We won't be using like kg. We won't be using grams for mass. We will use kilograms. for length, we won't use centimeters or millimeters. We will use meters. But that depends on the chapter, the topic, and the questions. Next, derived quantities. Derived quantities are physical quantities that is derived by combination of base quantities. We need to memorize this because this is the definition of derived quantities. Physical quantities that is derived by combination of base quantities, and it can be done by multiplication, division, or both. We can also put this in your definition just in case. So basically, okay, these are the base quantities, right? And this one cannot be defined in other terms of physical quantities because they are the OG. So, derived quantities are combination of base quantities. And we use multiplication, division, or both to combine the base quantities to become derived quantities. Okay, for example, area. The unit is meter power of 2. Meter power of 2 means meter times meter, m times m. So that is the multiplication of the base quantity length. M times m will become m power of 2. Other than that, volume. The unit m power of 3. M power of 3 means m times m times m. So we use the base quantity length, the unit m, and then we times it 3 times and we'll get this unit, m power of 3. Density. The unit is kilogram meter, kilogram per meter cube. Kilogram per meter cube. If there's a negative here, that means it's divide. So the formula for density is mass over volume. So the mass is kg from the base quantity, and volume is from here. We say m times m times m will become m power of 3. So kg over m power of 3 will become this unit. Speed. The formula of speed is I forgot the word. Distance over time. Distance over time. Distance is length. Distance is length. That's the base quantity. And time is seconds. Here, also base quantity. So, distance over time. ms negative 1. Okay, acceleration, meter per second per second. So, the formula for acceleration is the speed, the change of speed divided by time. So the speed, this, and then we divide by time here, the base quantity. So you'll get ms negative 2. And basically derived quantities are any physical quantities that are other than base quantities. So base quantities can only have 7, and all the other quantities are derived quantities. Alright, let's move on. Scalar and vector quantities. Just now was base and derived quantities. Now, physical quantities in the term of scalar quantities and vector quantity. So, scalar quantity, the definition is physical quantity that has only magnitude. We need to memorize this as it is a definition. Physical quantities that only has magnitude. Magnitude is the value. Alright, so this has only magnitude. And vector quantities are physical quantities that have both magnitude and direction. Magnitude and direction. That means it has the value and it also shows the direction of the quantity. So, for example, the scalar quantity, examples of scalar quantities are distance, speed, time, mass, energy. This only has magnitude, and it doesn't show the direction using the number. So basically, scalar quantity, they show no direction, and the value is always positive. Always positive, because in physics they use the positive and negative sign to show the direction of the quantities. But A scalar quantity has only magnitude, so you don't need the negative sign to show the direction. So for scalar quantity is positive value only. But then for vector quantity, for example, displacement, velocity, weight, force, and acceleration, we can show directions from these vector quantities. There are more actually. These are just examples. There are more. Okay, so there is direction because the definition says so. Magnitude and direction have both magnitude and direction. So that means can show the direction, and the value of vector quantities can be positive or negative. So let's say, for example, displacement. Displacement is same like distance, but distance has no direction. So distance, let's say for example, how to say? Alright, let's use these circle things. So look at my cursor. So this little blue ball wants to move. Okay, it's going to move 4 units down. So 1, 2, 3, 4. And it will go 3 units back. 1, 2, 3. So the distance of my cursor moving is 1, 2, 3, 4, 5, 6, 7. Oh my god, 6, 7. Okay, so that's the distance of the movement of my cursor. But what about the displacement? The displacement is different because the quantity has direction and it uses positive or negative. So 1, 2, 3, 4. And when it goes back, it will become negative, so it's minus. So minus 3. 3, 2, 1. 4 minus 3 is 1. So the displacement of this cursor is 1. We will learn more about this in chapter 2, so don't worry. So you just need to remember that scalar quantities has only magnitude and vector quantities has both magnitude and direction. Next is the relationship between variables of a graph. This we must memorize because we will be using it in paper 1, paper 2, and paper 3, and most especially paper 3. So the first graph. Okay, so there's this graph, y against x. The graph, the line here, starts from 0, 0, 0, which is the origin. Starts from here and it goes up. So this is y is directly proportional to x, which means if y increase, x also increase. Next, the graph will either start from the y-axis or from the x-axis, and then it will just go up. So this graph is y increases linearly with x. So y increases with x, but linearly. Linear means straight. So it will increase straight. Next, the graph starts from the y-axis and it goes down, straight down. So this one is y decreases linearly with x. Y decreases linearly with x. When it goes down, it decreases. Y decreases with x. And since the graph is straight, it decreases linearly. Next, y is inversely proportional to x. This both graph is inversely proportional. So, inversely proportional means if y increase, x decrease, and vice versa, which means if x increase, y decrease. So you see this one, the y is decreasing, but the x is increasing. So if it's y against x, the graph will look like this. It looks like, I forgot what the shape is called, but it looks like a slide, a water slide. That's how you remember. And also, the other graph is y against 1 over x. 1 over x. This one is y against x. this one is y against 1 over x. So it will look like the directly proportional graph. And next, y against x, but it starts from the y-axis and it decreases. It just decreases. So y decreases with x, because this is not a linear line. It's not a straight line. It's just a curve. So y decreases with x. So when y increases, x also increases. Next. Okay, this one is also y decreases with x. It also starts from the y-axis and it also decreases. So you see, this one goes like this, and this one goes like this. It still decreases. Next, y increases with x. This too is y increases with x. So it starts from the origin, 0, 0, and it increases. This one, it also increases. Next, how to analyze a graph. To analyze a graph, we use this in paper 3, experiment paper. Alright, so the first one, gradient of the graph. How do we find the gradient of a graph? So, we take one point, and then we take another point. So we connect them with dotted lines, and then it will be a triangle. And then to find the gradient of the graph, the formula is m equals to y2 minus y1, x2 minus y1. X2 minus x1. Okay, this one I don't need to really explain that much because we already learned this in Maths Form 2. Next, interpolation. Interpolation is to find the value of x when y is at a certain value and vice versa. So basically, we have y and we're looking for x. So we will draw dotted lines until it touches the graph and then continue the dotted line down, and then we'll see the value of x. And vice versa, we have x and we don't have y and we need to find y. So we will draw a dotted line up, dot, 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 until it touches the graph, and then we continue until it touches the y-axis, dot, 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 and then we'll find the y. Okay, next, area under the graph. As you can see this graph, we need to find the area. So we can split the sections into two. Split, split. So you'll get a triangle and you'll get a quadrilateral or a rectangle in basic language. So basically we need to find the value of triangle, and the formula to find the area of triangle is 1 over 2 length times height. H is height. Length, L is length. So 1 over 2 times length times height. So this is the length and this is the height. And to find the value of the length and the height, we will follow the axis. So the length, we will use x-axis, and the height, we will use the y-axis. And then we find the area of the quadrilateral, and the formula is length times length. So we determine the value here and the value here. Here, we can follow the y-axis, while over here, we need to use this value minus this value, and then we'll get the length here. But if you guys don't, and then after that, you guys need to add the triangle and the square together, and then you'll get the area under the graph. But for quickly, we can just use the formula for trapezium, because this is a trapezium. The formula is 1 over 2 times a plus b times height. So the a is this one, the b is this one, and the height is this one. Okay, and lastly, extrapolation. So let's say, extrapolation is to find other information by extending the graph. So let's say the graph is like this, and it's not connected to any of the axes. So let's say we need to find the y-axis. So we will extrapolate dot 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 until it touches the y-axis. Then we can find the y-intercept. And that is all for chapter 1. Thank you for watching. I hope you guys can understand. Yeah, that's all. Oh my god, that took like 20 minutes. Okay, thank you.